next topic. Okay. The next topic that we are going to see is that foreign key. Okay. There is something called foreign key. Okay. Now I say select star from my table. My table, I am assuming that is the employee master. It contains the details of all the employees. Okay, good. Now let me delete from payslip. Okay. Now let me select any record. Select star from payslip. Remember the first class. RDBMS, the purpose of RDBMS itself is to establish the relationship between tables. Assuming that this is employee master, which is containing employee ID and name, in the payslip, only one of these employee IDs can exist, correct? In that organization, how can I have a payslip for which there is no employee ID existing, right? Always the HR will add that employee first, then the finance department will have the employee payslip. Whereas previously when I defined this table, I have not given that rule, a rule meaning some order to the database to maintain the relationship. So I just like that created payslip table, and it happily allowed that also. I can add employee number 1901, which is not present in my table. But in ideal situations, if you take a railways reservation system and take a particular ticket, a ticket will be stored in a separate table, maybe tickets master, something like that, and it will have train number, date of journey, etc., etc. That train number must be available as a record in the train master. Okay, because there will be other table in which the train information will be stored. That means train number is a primary key of one table. Okay, here if I describe my table, this has got employee ID as not null, and this is the primary key. If I take payslip, right? Okay, let me say drop payslip. Ideally, I should have drop table payslip. Ideally, the employee ID value of that employee ID in the payslip table must exist in my table. Otherwise, if somebody tries to insert, it should give a warning, or it should give an error message. How to do that? How to establish automatic relationship between tables? That is called foreign key relationship. Foreign key relationship means primary key of one table must appear in another table. If that record doesn't exist in one table, it should not allow that value to be inserted in another table. Let me show you with an example. Before that, how to create a foreign key in a table. As now I have to create the table. Create table, payslip. Now I have to add the columns, right? EMP ID, number, right? Then MMYY, character of 4. Then that means a sal, number of 7,2. Okay. Yesterday we finished up to this portion, but we have not established a new rule. Now I am going to say the value of employee ID that you are giving over here must exist in another table. To do that, okay, to do that, there is a separate syntax we need to refer, that is called foreign key syntax. Okay, we need to create a constraint. Constraint meaning, okay, constraint meaning a rule, a condition. I say constraint. Constraint, I say foreign key, FK. Again, you have to give some name. Now, just watch. This is the syntax. Constraint meaning it is a rule. It's a condition. You have to give a name for this condition. I say FK, FK indicating foreign key. You can give any name, A, B, C, X, Y, Z, anything you can give. Now, I say foreign key. Again, this is a keyword. Foreign key, I have to give within brackets employee ID. Okay. Foreign key employee ID, that means the key that I am the column I am referring over here. Another keyword, references. References meaning it will always check against that. Okay. Foreign key references the table name within brackets, for example, my table within bracket emp id. Okay. This is the syntax. Now let me just try to create this. Okay. Just watch the syntax. You give all the column definitions as usual. Absolutely, there is no change in that. Additionally, to create the foreign key, you are saying constraint, a name foreign FK, keyword foreign key, employee ID. That means this column of this table references my table's employee ID. Right? This is the table name. This is within bracket that column name. That means I am establishing a relationship between my table's column employee ID and payslip's table column employee ID. This is just a syntax. To create the foreign key, you are creating a constraint. Constraint meaning rule. Okay, Nagarajan, how is it being used now? This is the key now. How is it getting used in real life? Remember the rule. Whenever you are giving a foreign key and you are giving a column over here, this column of this table must be a primary key of this table. Okay. If I try to give any other column name like designation, it will not allow. Primary key of one table must be available in another table. That is what the foreign keys concept. Okay, how is it used? I think you will understand it when I use it better. Okay, let me do a select. Select star from my table. Good. It has selected a lot of values. Now I am going to insert a value to the payslip table. Okay, insert into payslip values 101. Okay, 0409. Salary is 123. I am giving this value, right? Someone is asking it out. Employee ID is not defined as a primary key in my table. No, we have defined it as a primary key of my table. We have defined it as a primary key. That's why it's not allowing any duplicates over here. Okay, now I have inserted this value into this. Okay, good. It has inserted. Let me select star from payslip. Okay, one record inserted. While inserting, what he checks is I have given a value 101. He will first go and then check in my table. Is there an employee ID 101 in my table? Then allow the insert. Now I am going to insert into payslip values. Now I am going to insert a value 901 0409 345. Watch here. The moment I did that, integrity constraint violated, foreign key, parent key not found. That means when I gave 101, he went to this my table, he checked whether that value exists. Yes, it is there, so allow him to enter. Now when I give 901, he went to my table, checked whether an employee 901 exists in this table. It's not existing. Then it is saying integrity constraint violated. That is the precise purpose of foreign key. If the data is present in another table, allow. If that is not available, don't allow. That is where, if you look at the create statement, you would have understood it better. Foreign key employee ID of payslip table references my table's primary key employee ID. So before inserting an employee ID value into payslip table, always check in my table whether that ID exists. If it doesn't exist, don't allow. This is precisely one of the major uses of RDBMS. Integrity, referential integrity. If a value exists in one table, allow here. If it is not there, don't allow here. That means I am establishing a relationship between two tables. One table may have any number of foreign keys, but it can have only one primary key. Okay, so it can have any number of foreign keys, but it can have only one primary key. Is this concept clear? Foreign key. Can you please raise the hands? Okay, good, very good. And especially in Open Mentor, you could have observed that we talk very slow so that people understand in the very first step, and we always try to repeat. Most of the times, whenever I tell a point, I tell it once again, okay, so that you could get that, right? Primary key is always unique. Foreign key need not be unique, right? For example, I go here, select star from payslip, right? Employee ID is a foreign key over here, 101. Now try to insert another value. Insert into payslip values, one more value for 101, 0509, comma SAL, right? Sorry, I have to give a value there. $145, okay. It allows, right? So primary key, it is always unique. Foreign key is not unique, right? Constraint meaning you are putting a condition. Constraint is a keyword, right? Constraint meaning you are putting a condition to the database. Is this concept clear? Today we have covered left outer join, right outer join, substring command, seal, floor, round, and foreign key. These are all the areas that we have covered today. Any doubts in these areas? I'm open. Let us wait for some time, then we proceed. Okay. Any questions in this area? Good. I could see since the questions do not come, I'm sure that you guys have got a good grasp of these concepts, right? Someone has asked, how can I see all the tables in the current environment? There is a command, select table underscore name from user underscore tables, okay? User underscore tables is a built-in table. From there, you can see, if you say select table underscore name from user underscore tables, it will show all the table names. For example, the my table appears over here. There are so many other tables under this along with the installation that came. So all the tables within this will be available, okay? Someone is asking, is it necessary to give a name to the constraint? Yes, I use the constraint for constraint a name called FK. You can give any name, but you have to give a name. Yes. Good. That's very good. Someone has asked what is a wildcard that we have used. As we saw yesterday, like in the like statement we have used a percentage sign as a wildcard. So that is used as a wildcard. Percentage sign is used in queries as a wildcard. Okay. Good. Now, we can have many foreign keys for a table. Someone has asked, can we have multiple foreign keys to a table? Yes. But one foreign key must always refer to one other primary key of one table. You cannot have this foreign key A referring three different tables and columns. It cannot happen. One foreign key always points to one other primary key of some other table. But within a table, if I have 5 columns, I can have 5 foreign keys. Absolutely no issue. Okay, good. Now, just one second. Okay. Now, before going to the next session, I would like to have a theory part on stored procedures. Okay. I'm talking about stored procedures. Someone has asked the question, using foreign key, can we join the tables? See, foreign key is only to establish a relationship between the tables. For referring in the join, you can use any column. When it comes to join in the where condition, you can use any column. It can be a primary key column, it can be a foreign key column, it can be a normal column, right? Right. Absolutely, there will be no issue. Right. Now, before proceeding to the stored procedure syntax, today I would like to just give the theory behind stored procedures. Okay. Probably we may have to extend the class by one more day, probably next week, because the Oracle webinar used to end on I think Tuesday, suppose, but we may extend it by one more day because to cover the stored procedures, if possible, if I'm not able to finish it. If I'm able to finish it, not an issue. Stored procedures allow you to program within Oracle. Okay. Because what happens is when we are using programs like say JSP is the front end. Some logic is implemented there. It calls a Java class. Some other logic is implemented. Then the Java writes the data to the database. So I have a JSP syntax, I have a Java syntax. What happens is, ultimately, as I told in the first class, data or the information is the key for the customer. I want to keep the data intact. I can change the front end in any way. I can replace the JSP by ASP. I can replace Java by .NET as long as my data is correct. Now, what Oracle felt is, instead of having too many programming language, instead of having too many languages, have one language that deals with data directly. That's the key. Since Oracle maintains data, what they suggested is, I can give you a programming language that can directly deal with data. So why do you need so many other programming language? If at all you need a programming language, use only maybe a web-based JSP or something like that. You can eliminate the in-between Java layer or .NET layer. So have the front end, have a back end directly, use everything in my database itself. Stored procedures, also known as SP, right? SP resides in database itself. So it accesses data much faster. If I move from one platform to the other platform, from Java to .NET platform, my data is still intact. Most of my logic are in Oracle, so I am not much worried about changing my programming language. That is the core aim to provide PLSQL, programming language SQL. So PLSQL is a full-fledged programming language that you can implement all your business related logic in that. So both data and the program will reside in database. That is the primary aim. Now what they have done is, within stored procedures, there is something called packages and standalone procedures. Okay. Packages and standalone procedures. Again, we are going to deal with what is the syntax and what is the use of them. Standalone procedure meaning it can independently execute. It is not part of any other thing. Packages meaning it is residing inside a container. Okay, package meaning a container. That package may internally contain, a package may internally contain procedures and functions. Okay. So a package is nothing like our Java file, right? A Java file will contain classes and methods. Same way, a package will internally having more procedures and functions. Whereas when you have standalone procedures, it can have only one function or one procedure. So it is not contained within anything. But purpose-wise, whatever a standalone procedure can do, a packaged procedure also can do. So it's nothing but creating programs. The way I can create programs in C, the way I can create programs in Java, I can create programs in PLSQL also. This package has, okay, header and body. There are two components. The package has a package header and a package body. How to create the header, how to create the body, we will see in the next class, not today. When I said package procedure or a standalone procedure is equal to any programming languages, that meaning, so I can have variables, I can have if conditions, I can have loops, right? I can have comment, right? Pretty much anything that I can do in C or in Java, I can do it in PLSQL. As simple as that. Exception handling. So a full-fledged programming language is also provided by Oracle, which is called PLSQL. In the next class, what we are going to see is how to write programs using PLSQL, right? And we will see how these are implemented, how these are compiled, how to write, how to print the values, how to implement the logic in the next class. This is the theory behind PLSQL stored procedures. Is this clear? Okay, good. So I think that pretty much covers today's portion of OpenMentor.net in Oracle. I'll probably stop the webinar here today. We will continue in the next class on how to write stored procedures with the syntax with some examples. Is that okay to you all? Okay. Cool. So stored procedure is going to be on Monday. It's not Tuesday, it's Monday. Okay, this the next class is on Monday. Good. And again, I would like to have another announcement. We have got more webinars uploaded to the Open Mentors online courses. Please use them and give us the feedback. Thanks a lot. I'll end the webinar today now. We will continue on Monday. Bye.